Find the particular solution for the differential equation y double prime minus y prime plus 9y equals 3 sine of 3t. So as always, we need to find our homogeneous solution, which would rearrange this equation to be the normal left-hand side equals the right-hand side of 0, where we create our auxiliary equation of r equal to the amount of derivatives being taken on y. So r squared would be 2 primes minus r, 1 prime, plus just 9, since there are no primes, equals 0. Unfortunately, you can't easily factor this, so we have to use our quadratic formula, minus b plus minus square root of b squared minus 4ac over 2a. Plugging in a equals 1, b equals -1, and c equals 9 for each coefficient. So minus b is minus 1, or positive 1, plus minus square root of -1 squared is 1, minus 4 times a, 1 times c, 9, over 2a, or just 2 times 1. This equals 1 plus minus square root of 1 minus 36 over 2, which equals 1 plus minus square root of -35 over 2. And there are no square numbers for 35, so we have our R homogeneous solutions equal to 1/2 plus minus rad 35 over 2 times I. So we need to keep this into account when finding our y particular solution, which will follow the general format of, I need a lot of space here, t to the power of s. And we have to keep into account that there's a sine term now, so it makes our solution even bigger. So t to the power of s times decreasing polynomial of degree m, so a sub m times t to the m plus a sub m minus 1 times t to the m minus 1 plus so on and so forth until a sub 1t plus a sub 0. This is just up to some degree m, but you can quickly see that we have no t terms here, disregarding the sign, times e to the alpha t, a little different than if we had no sine term, times cosine of beta t, plus everything all over again except now for the sine term, so t to the s, and now to differentiate the coefficients we use b instead. E to the same alpha t, but now sine of beta t. It doesn't matter if you put sine before cosine or not, it's interchangeable. And we can quickly see that in regard to this format, m for us equals 0. I'll put that here. There is no t term, since it's t to the power of m. And we can quickly see that for our alpha and beta, or our particular solutions, alpha is 0. For our particular, alpha equals 0, since there is no e term, and e to the 0 is 1. However, our beta is 3. Is that the same as our R homogeneous solutions of alpha equaling 1/2 and beta equaling rad 35 over 2? Obviously not. So, no repeated solutions, so s equals 0. And that's all we need now. For y particular, we set it equal to t to the s, 0, and we have no t term, so all of this gets disregarded until our a sub 0 term, times e to the 0 t, since our alphas were 0, times cosine of 3t, keep that the same. Now for our sine term, again t to 0, but now b of 0 constant, e to the same 0t, times sine of 3t. Essentially, this gives us all our possible solutions we can have, and once we set it equal to what we have over here, then we can find our undetermined coefficients. And simplifying, that's a sub 0 cosine of 3t plus b sub 0 sine of 3t. You can turn this to a and b, but I'm just going to keep it explicit. So now we have our yp term. I'll rewrite down here. And we have to take our two derivatives to plug this into our normal left-hand side and right-hand side. So here's where a little bit of Calc 1 comes into play. Yp prime for y particular prime is the derivative of this whole term. So derivative of cosine is negative sine. So put a negative out. And also there is a 3 inside, so whatever coefficient of the independent variable, you also have to bring in front. So minus 3, a sub 0, sine of 3t, plus derivative of sine is a little easier, that's just cosine, and remember to keep the 3 out as well. so 3 times b sub 0 cosine of 3t, and you just leave a's and b's by themselves since they're still just normal constants. And we do this one more time, yp double prime equals derivative of sine is cosine, bring another 3, so negative 9 a sub 0 cosine of 3t. Derivative of cosine is negative sine, so minus times another 3, negative 9 b sub 0 sine of 3t. If you notice, all these terms are just oscillating between sine and cosine, including the sign differences as well. Now is the fun part where we plug all of this back in to our y double prime minus y prime plus 9y equals 3 sine 3t. There will not be enough room, but I'll try. So y double prime is negative 9 ace of 0 cosine of 3t minus 9b sub 0 sine of 3t, trying to write as small as possible, minus y prime, which is minus 3 a sub 0 sine of 3t plus 3b sub 0 cosine of 3t plus 9y, which is our simplest term, a sub 0 cosine of 3t plus b sub 0 sine of 3t. And that all equals, I'll move it up here, 3 sine of 3t. So let's do a little bit of simplifying. Without even doing anything, you can immediately tell by inspection, negative 9a cosine of 3t gets cancelled all the way over here by plus 9a cosine of 3t. So you can cancel these two terms out. Likewise, negative 9b sub 0 sine 3t plus 9 distributed times b sub 0 sine 3t, those two cancel out, which leaves us with a much better positive 3 a sub 0 sine of 3t minus, don't forget, this goes to both, 3 b sub 0 cosine of 3t equals 3 sine of 3t. You can drop the 3's since they all have them, and we are left with this expression. So we're going to have to make our system of equations such that a and b are set equal to something. So there is no cosine term. We still have to include that plus 0 cosine of 3t. So now every single term has its equivalent on the right-hand side. Starting with the sine terms, I'll put our sine of 3t term here, which is just a sub 0 on the left-hand side. We can cancel out the sign implicitly, equals 1. There is no other coefficient here, and that's our first variable. Now for our second variable, cosine of 3t, we have minus b of 0, get rid of the cosine, equals, and again, since there is no cosine of 3t, I had to add the 0. The coefficient's just 0, so b sub 0 equals 0. And now we have our y particular solution with all the correct coefficients. Looking back to this term here, it equals a sub 0 cosine of 3t, so with a sub 0 equaling 1, it's just cosine of 3t. And b sub 0 is 0, so 0 times this term is all just 0. So that's all we had to find. It was just cosine of 3t. Kind of a waste of time, honestly. There are much better ways of doing this, but it's still important to know how method of undetermined coefficients works. In some cases, it is a little more efficient than Laplace or variation of parameters, but you know, the question asked for it, so we gotta do it. And we don't have to write our homogeneous solution though. That's just helpful to see if there are repeated roots. So I hope that helped. If it did, please like and subscribe, and I'll see you in the next video.